Well, hello everybody. Here's what you missed in class the other day. I covered section 1-5 with your class. We also took a homework quiz, which is right there. I also gave them back their quizzes from the other day. And then I began to solve what we call inequalities with them. You have seen this before in Algebra 1, so it should be easy for you. It's just some simple algebra involved. There's one rule that I need you to remember, and after that, you're going to be very, very successful on this. What the next few slides show for you is the answers to last time's worksheets. So you can always pause the video and check your answers if you'd like. There's your next page of it. Hey, notice that I put my answers in the cool parentheses, the braces. There's your third slide, your fourth, and of course your last. But those are the answers to what we had the other day. Now let me jump right into the lesson then. What we mean by inequalities is this. If you see the word inequalities, that means you're going to see one of these four symbols. You're going to see this, which means greater than. You might see this, which means greater than or equal to. You might see this symbol, which you're going to guess is less than. And you're going to see that symbol for less than or equal to. That's what we mean by inequalities. When we solve them, we're going to treat it just like it's an equal sign. So that part's going to be easy for you. There's only one rule I need you to remember when we work with inequalities. Here's what I'm going to do. I'm going to give you something that I think is a true statement. I'm going to give you that 5 is greater than 3. I'm going to ask you if that's true or false, and I'm hoping that you would say, duh, that's true. Now I'm going to perform some various operations on both sides. I'm going to add 2 to both sides, yielding me 7 is greater than 5. True or false? Yeah, that's true. So I've added a number to both sides. Let me subtract a number from both sides. 5 minus 5 is 0, is greater than. 3 minus 5 is negative 2. Yep, 0 is greater than negative 2. If you think about it on terms of a number line, 0 is to the right of negative 2. So yeah, it's greater. Hey, let me multiply by some positive number. So let's multiply both sides by 3. So I'm going to have 15 is greater than 9. That's still true. Now let's look at what happens though if I multiply by a negative number. 5 times negative 2 is negative 10, is greater than 3 times negative 2 is negative 6. That, my friends, is false. There's only one rule I need you to remember on inequality. If you multiply or divide by a negative number, you got to flip this sign to make a true statement. That's the only thing you have to worry about. Now, if you look at your note page, I have this summarized in a confusing looking chart. But here's what this chart says. Let me get black ink here. This says if you add a number to both sides, you don't have to do anything special. This one says if you subtract a number from both sides, you don't have to do anything special. Over here, they're talking about values of C. It looks really confusing the way they did it, but it basically says this. If you multiply or divide by a positive number, you don't have to do anything special. But here's the one rule. If you multiply or divide by a negative number, you got to flip the sign. After that, my friends, it should be an easy lesson for you. Look at your class examples there. I'm going to click through the algebra, mainly 1 because it's a video. 2, I don't want to give you time to type it in your calculator, so watch how I handle this and we'll go from there. On number 1, I'm hoping that you would say distribute first. So I'm going to get 49a minus 63 is less than or equal to 84. I'm going to add 63 to both sides. So now I'm at 49a is less than or equal to 147. I'm going to divide both sides by positive 49. And I'm going to get a is less than or equal to 3. Since I divided by a positive 49, I didn't need to do anything special. To write it in set builder notation, it looks like this then. I'm going to do the cool parenthesis, the brace, and I need to say a such that a is less than or equal to 3. Surround it by the parentheses, come down here on the graph, close dot. The reason it's closed is because of this or equal to. If you have a line underneath your inequality, it's a closed dot. And I'm going to come to the left. Now you might have had Mr. Fonestill, Mr. Dreher. Sometimes they like to have you shade on the number line. I don't mind you shading on the number line, but I got to be able to tell which direction you're going. That's why I come up and over. It's easy for me to tell what you're doing. If you'd rather just shade it in darker with the arrows, I'm okay with that also. Number 2, let's distribute this 3. So I've got 27z plus 12 is greater than 35z minus 4. When you solve inequalities, guys, get your variable on the left. So I'm going to subtract 35z to both sides. Going to yield me negative 8z plus 12 is greater than negative 4. Let's subtract 12 from both sides. So I've got negative 8z is greater than negative 16. I'm going to say out loud what we're going to do now. We need to divide both sides by negative 8. Hey, that's our cue that since I'm dividing by a negative number, I need to flip that sign. So it was a greater than, now it becomes a less than. Negative 16 divided by negative 8 is 2. To put it in set builder notation, I'm going to go z such that z is less than 2. Put the braces around it, and we got our notation all done. To graph it, since it just says z is less than 2, I need an open dot on 2, because it does not include it, and I need to come to the left. The reason I like the variable on the left is this sign will point the direction you need to go. So that's why we're always going to try to get our variables on the left. Here's my number 3. I kind of purposely flipped this one around a little bit. So I've got 165 is greater than 60 minus 15n. We need to get our variable by itself, so let's subtract 60 from both sides. So now I've got 105 is greater than negative 15n. Let's divide both sides by negative 15. Hey, now here comes my pause. Since I'm dividing by a negative number, I need to flip the sign. So I'm going to have negative 7 is less than n. We do not want to leave the answer looking like that. I want my variable on the left. So what I'm going to do is write it correctly. I've got an n on this side and a negative 7 on that side. Notice my symbol is opening up towards the end, pointing at the negative 7. I need it to do the same thing. And I still need to do set builder notation. So I've got n is greater than negative 7. So let's open dot negative 7. And greater than is going to go to the right. Otherwise, guys, there's just more algebra coming to you. You got the concept down. I'm going to click through the next 5, 6, 7 problems just to review the algebra for you, and then we should be good to go. Here's my number 4. I've got 18 minus 4k is less than 2k plus 42. I need to get my variables on the same side, so I'm going to subtract 2k to this side, leaving me 18 minus 6k is less than 42. I'm now going to subtract 18 from both sides, so I've got negative 6k is less than 24. I'm dividing by negative 6, so I'm going to have k is, flip your sign, greater than negative 4. To put it in set builder notation, let's go set k such that k is greater than negative 4. Put my set builder parentheses around there. To graph it, open dot on negative 4, and I'm coming to the right. Here's my number 5. Let's distribute first, of course. I've got 4b minus 28 plus 6 is less than 22. Combine like terms, so I've got 4b minus 22 is less than 22. Let's add 22 to both sides and get 44. Divide both sides by 4. So I've got b is less than 11. In set builder notation, b such that b is less than 11 with my braces around it. Ask yourself, open dot or close dot? So I should see an open dot on 11. Less than is coming to the left. So there's what we've got so far. Here's my number 6. If I distribute correctly, I'm going to have 2 plus 3m plus 15 is greater than or equal to 4m plus 12. Combine any like terms. So on the left-hand side, now here's a common error that I see people do. They like to go minus 2, minus 2. Don't do that, because if you look at it, guys, you just subtracted 4 from this side, but you didn't do anything to this side. Since they're on the same side of the inequality, just combine them. So I'm going to have 3m plus 17 is greater than or equal to 4m plus 12. Keep hashing it out. I'm going to subtract 4m from both sides. So I've got negative m plus 17 is greater than or equal to 12. I'm going to minus 17 from both sides. So I've got negative m is greater than or equal to negative 5. Hey, notice this. I did not flip the sign. I didn't multiply or divide by a negative number. I subtracted a number. So don't flip your sign. But now I need to flip my sign right here, because I'm going to divide both sides by negative 1. I'm going to write that down here. So I'm going to have m is less than or equal to 5. And I'll go m such that. Make it set builder notation by putting this parentheses around it. Close dot on negative. Close dot on positive 5. And I'm coming to the left. Like I said, guys, if you keep your variable on the left, this points the direction that you need to go. Let me click through a couple on the back. In class, I paused and had them try a couple, but let me hit number 7. I'll show you how to handle that fraction, and then I may drop down to number 10 or 11. So number 7, I got 4x minus 2 is greater than negative 28x plus 14. Notice I distributed the negative 7, and a negative made a positive. Let's add 28x to both sides. So I've got 32x minus 2 is greater than 14. Let's add 2 to both sides and divide both sides by 32. Some people get in a hurry and say 2. But if you divide both sides by 32, I'm going to get x is greater than 1/2. I would also take 0.5. Since 0.5 is a rational number, it terminates. In set Miller notation, x such that. Hey, now notice on the back side here, though, guys, I didn't give you a number line. I didn't give you a sweet little number line. So you got to come up with your own. So I'm going to put 1/2 right there in the middle. And then you got to give me the two integers that 1/2 is between. Well, 1/2 is between 0 and 1. So now to graph it, open dot on 1/2, and I'm going to the right. So moral of the story, if you're not given a graph, and most of the times you won't be, you have to show me the number that your answer is between. Number 8, I'm going to show you the easiest way to do number 8. I could ask you what you don't like about it, and I know what you're going to say, the fraction. So here's what I'm going to do. I'm going to multiply both sides by 3. Check out what happens if I do that. 3 times 1/3 cancel each other out, because 3 over 3 is 1. So on this side, I'm left with 2y minus 3 is greater than. Distribute that 3, so I got 3y plus 15. That way my fractions are gone. Let's subtract 3y from both sides. So I've got negative y minus 3 is greater than 15. You could probably bring it home from here. Add 3 to both sides, so I got the opposite of y is greater than 18. Divide both sides by negative 1, which means I need to flip the sign. So I've got y is less than negative 18. Put that y such that in front of there, and boom, there's your answer. How do you graph it? You'll come down here. You got negative 18, open dot, and we're going to the left. But I need you to tell me what two integers negative 18 is between. And it's between negative 17 and negative 19. Okay. Hey, I'm going to skip number 9. I don't think you need it. Subtract 15, divide by 2.5. I think you're going to be golden there. Let me show you number 10, maybe number 11. On number 10, I could ask you, what do you not like? And I know the answer. The answer is, Mr. Harris, I don't like that 3. So we're going to get rid of that. We're going to multiply both sides by 3. And if you do that, I'm at 3c is greater than or equal to, because 3 times c. These 3's cancel out, which leaves me a c plus 4. Now look how easy that problem looks. I'm going to subtract 1c from both sides. So I've got 2c is greater than or equal to 4. Divide both sides by 2. So I've got c is greater than or equal to 2. I'm going to put the c such that c in front of there. When I come down here, there's my 2, close dot, and I'm going to the right. What two integers is 2 between? Well, it's between 3 and 1. And then one last one. Here goes our number 11. Once again, if you were in class, I would ask you, what do you not like? And you're going to tell me the fraction. So we're going to get rid of it. I'm going to multiply both sides by 5. 5 times 3h is 15h is greater than or equal to. This 2h plus 26 over 5 times 5, check this out. Those 5's cancel out, leaving you just 2h plus 26. Now there's no fractions. I'm going to subtract 2h from both sides. So I've got 13h is greater than or equal to 26. Divide both sides by 13. So I got h is greater than or equal to 2. Set Miller notation, h such that h is greater than or equal to 2. When I come down here, 2, close dot, and greater than, so I'm going to the right. And I know that 2 is between 1 and 3. So there's the lesson, guys. You should have your assignment sheet in front of you. We'll quiz next class over sections 1-2 through 1-4, and notice that there won't be any notes. So make sure you get through this lesson. If you have any questions, please buzz in and see me. Good luck to you.